Yo, what's up, guys? Okay, in this video, we're gonna talk about the evolution of human beings, Homo sapiens, right? Or any part of the Homo class, or whatever you want to call it, right? Because we weren't always Homo sapiens. There's a distinguishing factor between Homo erectus onward, right? What is it? So what is evolution? So naturally, a system is going to evolve to a higher level, right? Higher level meaning higher cognitive functioning, right? And with higher cognitive function, we begin to uh, create more and more complex machinery, right? We go from the age of iron, steel, moving parts, right? You get cars, right? Back in the 20s or the 30s, if I'm not mistaken, it's probably the 20s. And then from there, you just keep evolving up, right? And we begin to take advantage of fields, right? The electromagnetic field. And from that, we take advantage of what nature's always given us, right? Energy. We can take advantage of energy, right? This all comes together. We have brilliant mathematicians and physicists, and with this, we get all the technology you see around us today, right? And it's still evolving. It's 2020, still evolving, right? But Moore's law is going to kick in soon. We can't get transistors down below the size of an atom, right? We're approaching that size, right? So what has to happen there? We have to develop an efficient quantum computer. Now, times come. You hit these threshold points in human evolution where there's nothing you can do. You open up the genie in the bottle, right? There's no going back. Now, this is just the very beginning of reality, right? Everything that's come before us, you could say that human beings don't have any intelligence, right? You could call us something else now, right? Instead of Homo sapiens, we should call us Homo technologians or whatever the fuck. I don't know. Make a damn up for it. But whenever we cross the point of being able to have computers that are more intelligent than ourselves, we have finally entered the age of the singularity, right? The point at which it doesn't matter anymore, right? We don't need to work. We have universal basic income. You have all the food for every human being on Earth tenfold. So, what is it that a computer could do that we can't, right? We know what computers are good at. They can multiply big numbers. They can factor big numbers at unimaginable speeds, right? This is a function of the circuitry, right? You have billions of transistors, 30 billion in a PS4, right? It's coming out, yeah. So what can you do with all these transistors jam-packed? You can perform mathematical operations. You can you have programming languages that give you a wide array of capacity to compute, right? But this is good for computation. But what if I want to put an agent in that system? Like we are, right? We're an agent within a system. The system that's running this is probably a quantum computer, a super quantum computer that's probably millions of years of evolution ahead of us. But what do you do when you're in the simulation and you're not that far evolved, right? You're not that intelligent, So what do? You begin to, what did we do 100 years ago, or 200 years ago, when chemists were beginning to develop the periodic table of elements, right? They see there's some nature to these elements and how they react with other elements, and of course developed the notion of the phases of matter, right? It used to be thought that, there was only, water, fire, and ice, and, they didn't even understand that the materials could be extracted in various methods, and then they could take those elements and, play around with them. They didn't understand even the notion that everything is made up of little tiny elements, such as atoms, right? There's no capacity there. What is it in 2020 that we don't have the capacity to see? Well, okay, I'm telling you here, right today, that the singularity is going to hit in 2035. You guys hear me? 2035. And what will happen is, there's going to be it's going to be written in PyTorch. If you guys want to know the library you want to learn to get at a high level in machine learning, study PyTorch, um, work with OpenCV, learn a little bit about circuitry, right? Study some engineering side, the engineering side, right? That's important as well, because the software side's interesting, but if you can advance the hardware, right? Because I don't think intelligence is going to come from a classical computer running some algorithm that's embedded into some machine learning environment. I think it's going to come via quantum computing. You're going to take all the libraries we have today, like I said, PyTorch, but it's going to have to be run on a quantum computer, right? The reason why I believe that is because I believe the brain itself doesn't operate classically. It operates in a quantum mechanical way. And okay, that's my hypothesis, right? And I gave you a way of backing up why I believe that. So at the end of the day, I'm schizophrenic. You see, you draw some inspiration from the people around us today, brilliant minds of the day. A few people's names come to mind. You got Terence Tao, you have George Hotz, but then you have the cancer of the 21st century. The idea that Silicon Valley is advancing AI in any way. It's not. If anything, they're stunting the development of intelligent agents. They're more in it for the profit. And not only that, but they're focusing. I think Google is focusing too much, or Intel in AMD are focusing too much on advancing classical computing. Right? We constantly have every year better, more efficient GPUs. But when is it going to hit the point where we need to invest more research money, grant money, into quantum computers? That's where IBM comes into the picture. IBM is going to revolutionize quantum computers within the next, I'd say by 2030, right? Because I said the revolution of AI will hit the singularity in 2035. Classical or quantum computers will come 5 years before that, right? 2030, we're going to see the renaissance, the point of, you could even call 2030 the singularity, really. But we have to stick to strict definitions. But the hardware singularity will occur in 2030. The software singularity will hit in 2035. I'll put it that way. So, what can you do? What can you do? You're just a retard like me. What can you do? You have open source software. You learn the nature of reality itself. I always said, don't feel ashamed of just running chemistry experiments at your level. I've synthesized meth before. It's a process, right? It's about the process, understanding the nature of how chemistry works, physics works. That applies to learning computer science, right? Because at the end of the day, computers are running within the physics that govern everything around us, right? You look at the world around you, you think it's disconnected between the reality itself and what's inside that computer, right? Within the circuits. But they work in tandem, right? The circuits are literally the environment. You got to think of it that way, right? The transistors fire. They send some type of function or some input that you gave it, and then there's usually an output, right? Maybe I want to list. You do some machine learning project. Yesterday I got my webcam to put a bounding box around an object, and then with machine learning, I wanted to improve its understanding of the world around it. Right? What's the world around it? Well, this is an object. That's an object. It needs to understand at least what an object is, right? You give it a neural net. You give it some type of neural net. We have ReLU. We could have a convolutional neural net, um, and then based on the weight you give it, the time you give it, it's all about that time, right? That's why I'm saying quantum computers will revolutionize AI. It's all about the time it takes for it to learn. I don't want to have to develop a model like GPT-3. What I want to do is I want to develop a model like GPT-3 on my computer today. I can't do that. I can get the net that's already been established, that's already been built up on supercomputers, uh, but I want to be able to do that with the least amount of power, right? We're talking about efficiency here. The least amount of power, the least amount of computations, operations to perform a task that you throw at it. In that case, GPT-3 tried to, create human-like language interpretation, and not only that, but it could extrapolate its own text, right? It could if you told it write about Joe Rogan, and be creative. Maybe you hype up the you tamper with the creativity level. So that means it's not going to take its knowledge that it's already been shown. It's going to produce inferences based on what it's been told and its understanding of the definitions of words. Good, but it all comes back to that amount of computational power and the time. Quantum computers will bring that down substantially. Once we have personal quantum computers, which I believe it's possible, there's going to be some people that say we'll never have personal quantum computers. I think they're bullshitting you. I think there's brilliant engineers that are getting closer every single month. You see a groundbreaking paper that's released. It's going to be ushered in. It's going to be ushered in within the next, I said 2030, yeah. Because there's a lot of working with the programming. Yeah, it's hard enough to develop the machinery, right, the hardware of a quantum computer, but then you need to develop the software, right? And it's hard to develop programming languages on a quantum computer because of obvious reasons of the nature of what a quantum system is. It's just, you got a particle here, a particle there, they're entangled. Oh my God, you might get, the output will never be the same, right? You give it the same input, 1 plus 3, it won't always equal 4. And that's just the nature of what happens at this size, right? I'm just going to leave it at that today. I was a little all over the place. I didn't really plan this out, so that's all I have for today. Thank you guys for watching.